All right, we're going to start with this situation about pizza. Kathy and Bill opened a pizza shop. They sell small pizzas for $5 each and a large pizza for $8 each. Customers can get any combination of the 10 toppings for $1 per topping. So if we start with a small pizza, we got to spend the original $5. Then it's $1 per topping, and if we get 0 toppings, we didn't spend any money, so we have a cost of $5. If we continue this table, still the $5 per pizza plus $1 per topping, so now I'm at $6. So go ahead and fill in the rest of this table. Alright, so yours should match mine. I hope you noticed that this last row, they skipped from 5 toppings to 10 toppings, and so we needed to make sure we put that into our process. Moving on to the large pizza. A large pizza is $8, and so we'll have to start with $8 plus $1 per topping. We would spend $8. Go ahead and fill in this table. Okay, so this should be your large pizza table. Our independent quantity, remember independent is our input, it's our X, it's what happens first, it's our cause, so that would be our number of toppings. And then the dependent variable is what happens second, the effect, the Y, so that would be the cost. So this will help us when we're writing our equations, because our Y, which is our total cost, equals the $5 plus $1 per topping. And then for the large pizza, we have Y equals $8 plus $1 per topping. So another way that you could write that, let me extend this down. You could write this in our slope-intercept form, and we don't need this 1, so this could just be Y equals X plus 5, and this would be Y equals X plus 8. So this is the number of toppings you get plus the $5 base fee for the pizza, and this is the number of toppings plus the $8 base fee for the pizza. So we just wrote that in our slope-intercept form. The M is the slope, the B is the y-intercept. This is review. You don't have a place to write this down. And the name slope-intercept form helps us with the slope and the intercept. So when they're graphed, we just decided that our independent variable was the toppings, so that's the X, which goes down at the bottom. And our dependent variable is the cost, which would go on this side. This is really hard to write sideways. Oh. And then the same for the large pizza. This would be toppings, and this would be cost. So the equation in the graph, if you look at the equation versus the graph, the information from the graph can be found in the equation and vice versa. So remember, our small pizza topping was Y equals X plus 5. This is our y-intercept. It crosses here at 5. Our slope is 1. We go up 1, over 1, up 1, over 1, up 1, over 1. So both the equation and the graph give us the y-intercept and the slope. Same for this side. Y equals 1x plus 8. I have my y-intercept here. It's also located here on the graph. I have my slope is 1, up 1 over 1, up 1 over 1, up 1 over 1. So the equation and the graph, they both give us the same information. They give us the slope-intercept, and they give us the, they give us the slope and they give us the y-intercept. To review that concept one more time, we have this graph about the manufacturer custom brass buttons. It says it involves an initial setup fee and a cost per button. Remember, our fees deal with our y-intercepts, and our costs per, this keyword per, would deal with the slope. So it's easier to find the y-intercept where it crosses the y-axis at 400. So that is our fee. Y-intercept, fee, y-intercept, Phi, 400, they all connect. The slope, we're going up one box, which is up 100, and over two boxes, which is over 200. So our rise was 100, our run was 200, which equals 1 over 2. So that's our slope. So our equation is y equals 1 over 2x plus 400. And if we kind of relate it back to the problem, remember our initial fee is the y-intercept, which is the $400, and the cost per button is half, which if we think of that as money, half of $1 or 0.50, so each button costs 50 cents to make. And then there's the $400 initial setup fee. So why do we choose the slope-intercept form of a linear equation to write our equation of the line graphed? Well, because in the graph, it gives us the slope and the intercept, and so it's easy to write slope-intercept. However, did you know there's 3 different types or forms of linear equations? Probably not. So this is the one we've been using. The m is the slope, the b is the y-intercept, and so when we have these pieces of information, this equation is very easy to write. However, we don't always have those pieces of information, and so we can use other equation formats. Remind me to give you guys formula charts tomorrow to put into our journals. But we're going to look at standard form a little bit too. So on the back, we have a situation about swim team going to an out-of-town swim meet. They can take cars holding 4 people, vans holding 8 people, and they have 48 travelers, including swimmers, coaches, and parents. Write an equation to represent this situation. I don't have any y-intercepts. I don't have any slopes. I don't have any something's happening per something else, or there's no fees. This doesn't make any sense to use slope-intercept form. So this is another form we can use. First, we have to think about variables. Well, we have cars and we have vans. So let's do x equals cars and y equals vans. Then to write our standard form equation, our cars has 4 people each. So I can put 4 people in each car. Our vans hold 8 people each. So I can put 8 people in each van. I should use x and y because that's what I told you to use. 4x plus 8y. And then it says I have 48 travelers, so it has to equal 48. So if I think about this again, 4 people in each car, so if I find out how many cars there are, I can replace the x. 8 people in each van, find out how many vans there are, I can place the y, equals 48. So that is how I can write a linear equation in this thing called standard form. Let's try another one. Marta is a baker, baking cupcakes. She has 2 types of cupcake pans. That's kind of our key, that she has 2 types of something. One pan holds 12 cupcakes and the other holds 8 cupcakes. So we have x can be our large pan, and y can be the small pan. So the large pan holds 12 cupcakes. So if I make 4 large pans, I would do 12 times 4 to find how many cupcakes I had. That's why it's 12x. The small pan holds 8 cupcakes. And then write an equation to represent it if she wants to bake 8 dozen cupcakes. So I have to figure out how many 8 dozen is. 8 times 12, which is 96. So she wants to bake 96 total cupcakes. So there's my equation in standard form. I want you to try number 4. So you're going to have to put your equation into your feedback form, but I'll help you with the variables. So John's working on a science fair project. It'll take him 2 hours to complete each informational poster and 1 hour to complete each sample product. So he's making informational posters. We'll have that be our X, and sample products, and that'll be our Y. And he has to complete the project within 14 hours. So the X is the informational poster, the Y is the sample product, and he has 14 hours to complete it. So I need you to write your equation for that, and you'll be putting that into your feedback form when you finish. So here's the problem though. If I wanted you to graph either that swimming situation or the cupcake situation, you don't have a slope or a y-intercept to graph it. So we have to change our equations from standard form to slope-intercept form. So remember when we were doing all of that work with rearranging equations, and I told you it was going to be important someday? That day is today. So I'm going to rewrite this with the X and the Y so that you guys don't get confused. Remember when we're writing equations, it needs to be Y equals. So I want this Y all by itself. So to start, I have to subtract 4x from both sides, which leaves 8y equals negative 4x plus 48, and then divide both sides by 8. Y equals negative 4 divided by 8 is negative 1/2 x, and 48 divided by 8 would be plus 6. So now I could graph it with the y-intercept of 6 and a slope of negative 1/2. Let's try the cupcake one. We're going to rewrite it in slope-intercept form, meaning I want the y by itself. So I'm going to subtract 12x from both sides. 8y equals negative 12x plus 96. Divide both sides by 8. Y equals negative 12 divided by 8, which would be negative 3 over 2x, and then 96 divided by 8 would be plus 12. So that is how you change standard form to slope-intercept form. Don't forget to go back and do your feedback. You're going to have to put that number 4 into your feedback form, and then I'm going to make sure that we're okay on this part. I have a feeling this is going to be the tricky part. So go ahead and do your feedback, and I'll see you guys tomorrow.